Hi everyone, lesson 109, graphing systems of linear inequalities. We went through earlier in the year how to graph a system of linear equations. With linear inequalities, you're going to have two inequalities where you're going to have to graph and shade. And your solution is always going to be where are the two shadings overlapping. So a system of linear inequalities, two or more systems of linear inequalities, and then the solution is where they overlap. So let's take a look at an example. Solve by graphing these two inequalities. Y is greater than 1/4 x minus 3 and y is less than or equal to 3x plus 4. So I need to use my y-intercept and my slope to find my points. The first one, put a point and -3 on the y-intercept, on the y-axis, because that's my y-intercept. And I use my slope, positive 1/4, to find my other points. So I know my line's got to go up from left to right. So I go up 1 to the right 4. And then I can go down 1 to the left 4. And I'll just use at least 3 points so I can make my line as accurate as possible. Since my line is, since I have a greater than, I know it's going to be a dotted line or a dashed line. So I'm just going to draw my dashed line here through my points. And I know everything on that one is going to be shaded above the line, but I'm going to wait for the shading until the very end. My next one, my next line, I put a point at positive 4. And then I have a slope of a positive 3. That means it's going up from left to right. So I'm going to go up 3 to the right 1. And then I'm going to go back to my original point, my y-intercept, and I'm going to go down 3 to the left 1. And so I can see I have 3 points here. I'm going to, it's got a less than or equal to, so it's got the equal to sign. So I know I can draw my line. That's a solid line through those points. So I'm just going to draw my line through there with a solid line. So now I have my two graphs. All I need to do is do the shading and find out where do the shadings overlap. So I'm going to use a black for the first equation. It says it's got to be greater than that dotted black line. So I'm just going to draw lines so it's going to be greater than this line. And then the other one says it's got to be less than the purple line. So less than the purple line. It's going to be to the right. Okay, so everything below there is going to be a solution to that. And I can always double check that by picking a point. If I pick the 0, 0, 0, 0 is right here. Put 0 in for y, 0 in for x. Is 0 less than or equal to 4? Yes, so that's why we shade on that side. So now you can see which parts overlap. And I can erase what I don't need. So these I don't need on this side because this side of the line is not a solution. And then I know everything below the black dotted line is not a solution either. So I'm just going to erase all of those. And you can see everything in that triangle there is all a solution to our inequality. We'll do one more together, and then there's two more that you can do yourself. Here it says y is less than 4. So I go to the y-intercept, and I put a point at 4. And it's less than that. I know it's a dotted line because it's just less than, so I'm going to draw a dotted line through that point. Okay. The next one, I need to get y by itself. So I'm going to subtract 2 on both sides. So I have 2y is greater than -6x minus 2. Then divide by 2 on sides. So I have y is greater than negative 3x minus 1. So now I can put a point at negative, put a point at negative 1 on the y-axis. And then I use my slope, it's going down. So from left to right. So I'm going to go down 3, 1, 2, 3 to the right 1. Or I can go up 3 to the left 1. And since this one is still just greater than, I know it's going to be a dotted line. So I'm just going to use the same line I have here. It's going to be a dotted line through here. So there's my dotted line. Now the shading part. So the very first one, it's got to be below the horizontal line. So everything below this is a solution. And then the other one says it's got to be greater than the slanted line. So everything greater than the slanted line is going to be everything to the right of it. Everything to the right of that. Again, you could always use the 0, 0. Is 0 greater than a negative 1? Yes. And 0, 0 is right here. So I know that everything to the right of that line is going to be a solution. So I'm just going to draw my lines here. Okay, and then I'll look at where the two colors are intersecting, and those would be my solutions. So I don't need these on this side of the slanted line, because none of these are the solution, and anything, these three green lines at the top are not the solution. So just in this corner is where our solution would be. Now you can work on 1C and 1D yourself for extra practice. Example 2, using your graphing calculator to do the graphing. Here in the picture, you can't see it as well, so I'm going to get my calculator out so I can show you how to do that on your graphing calculator. So you need to go to the y equals button, and we're going to type in these two equations. So the first one, I'm going to use parentheses for fractions. So I have 3 divided by 4 in parentheses. That's my x plus 2. And then the bottom one, it's got to be parentheses negative 1 divided by 5 and parentheses x plus 4. And now the graphing part, I need to determine which side is it going to be graphing. The first one says it's got to be less than. So it's got to be the lower triangle. So again, I'm going to go to the enter button. And I'm just going to keep clicking enter until I see the triangle on the bottom, like there. And if I go down below, it's got to be greater than. So I'm going to keep hitting enter until I see the upper right-hand triangle, like that. Then I hit graph, and you can see here's the first line in the shading. Here's the second line, and here's the shading. And the darker part right here in this upper corner, this triangle, that would be the solution. So that's how you would do it on your graphing calculator. Example 3. What about when you have parallel lines? I'll show you how you're going to do the same thing, and then you're going to shade. The first one, y is less than or equal to negative 2/3 x minus 2. I'm going to plot my points here. First one's at negative 2. My line's going down from left to right. It's a negative, so I'm going to go down 2 to the right 3. Put a point there. Or I can go up 2 to the left 3. And since this has an equal to sign, I know it's going to be a solid line. So I'm just going to draw my solid line through those 2 points. The next one, I know that it's going to be the same slope, but this time the y-intercept is a positive 3. So I put a point at positive 3. And then I go down 2 to the right 3. Or I can go up 2 to the left 3. You can See my points there. My line again is going to be solid because it's got the equal to part with it. So I'm going to draw my line through there, solid line. So now I have two parallel lines. Now the shading part. To save some time and instead of doing a lot of erasing, I'm just going to put an X next to the part that needs to be shaded in. So for the first one, it says that X is, or the Y has to be less than or equal to the black line. So less than the black line, that means it's down here. The next one, it says it's got to be greater than the green line. Greater than the green line. That means it's up here. So if I were to do shading wise, the shading up here would be this part of the graph. And on this one, where the black X is, that's where I have to do the shading over here. So you notice nothing overlaps. So this would be no solution. Now let's look at one more here, 3B. Do the same thing. It's the same numbers, same graph. Only difference is the symbols are different. So let's do the first one. Put a point in -2. Use the slope -2/3, so down 2 to the right 3. Or go up 2 to the left 3. It's got the equal to sign, so I know it's a solid line. So there's my line. It's got to be greater than that. I'll put my X a little bit later on that one. And the next one, we have it's +3, but our slope's a negative, so I go down 2 to the right 3, or I go up 2 to the left 3. Solid line again, because it's got the equal to parts, so I draw my solid line. And now we can do the shading. So the last one I just did, the green one, it says it's got to be less than that green line. So less than the green line is down here. And the other one, it's got to be greater than the black line. So above the black line. You notice I have two different color X's in the same spot. That means that's where I'm going to do the shading. So I'm just going to use a different color. So this part right here, the blue, this is where all the solutions are found, in the middle of the two lines. You may do 3C and 3D yourself for more practice. And an application problem. Here it says Lena has to earn at least $210 per week from 2 part-time jobs. She can earn up to 15 hours per week at job A, which pays $12 per hour, and she can work up to 35 hours per week at job B, which pays $10 per hour. She is not allowed to work more than 40 hours per week. Graph the possible combinations of hours Lena can work per week. So there are going to be quite a few inequalities we need to write. So the first one, we're going to use X for job A and Y for job B. So it says she can work up to 15 hours per week at job A. So X, up to means it's no more than 15. So X is less than or equal to 15. Job B, up to 35 hours a week. So Y is going to be less than or equal to 35. And then we have Lena has to earn at least $210 per week from both jobs. So if she gets $12 an hour for job A plus $10 per hour for job B, it has to be at least, so greater than or equal to $210. And then the last one says that she is not allowed to work more than 40 hours. So job A plus job B cannot be more than, so up to 40 hours. Okay, so those are our equations here, but we need to solve some of these so we can graph them. So I'm going to subtract 12x on both sides. So now I have 10y greater than or equal to a negative 12x plus 210. Divide by 10 on both sides. Now I have y is greater than or equal to negative 6/5 x plus 21. And this one would just be y is less than or equal to a negative x plus 40. Now I'm ready to do all the graphing. So the first one, and to just get started, we can see that we have some pretty big numbers here, so we have to determine what our axes are going to be. Our y-axis, we can count by, and since we're only dealing with positive numbers, because we're only dealing with hours you can work and the amount of money you can pay, you're only dealing with the quadrant 1, dealing with all positives. So we don't have to worry about all the other parts of the coordinate plane. So to make it easier, since most of them are multiples of 5, we'll just count by 5s. So this would be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So this would be 50 up here. This is 5 here. And then we will just count by our x's, we'll just count by 1s. So this would be 1, 2, 3, 4, 5, 6. Actually, we'll have to count by, we'll count by 2s, just because I have to get to x equals 15. So let's say this is 2, 4, 6, 8, 10, 12, 14. That actually won't work either. So we'll have to just count by, we'll count by 3s. So this would be 3, 6, 9, 12, 15. So that should work for us. So here, let's draw our graph. So x has to be less than or equal to 15. So there's 15. Got to be a solid line on 15 because it's got the greater than. Okay, and then y is less than or equal to 35. So go to 35. So 5, 10, 15, 20, 25, 30. 35 is here. Also going to be a solid line, so straight across here. And then we have y is less than or equal to negative x plus 40. So I need to go to 40. So if this is 35, 40 would be right above here. And then I have to go down 1 over 1. Since we can go 3 over 3 because that would still be 1. So if I go down 3 over 3, actually no, let's go 5 over 5. So if I go down 5 over 5, so this is 3, 5 would be in the middle here. Go down 5 more over 3, so it'll be about here. So now I can draw my line here. It's a solid line as well. And then we have our last one, plus 21. So 5, 10, 15, 20. 21 would be about here. Slope is a negative 6/5. So a negative 6 down would give you to 15 over 5. So this is 3. This is 6, so 5. Be around here. We'll go down. Well, actually, we could just keep it there. Draw our line as well. Okay, so there's what our graph is going to look like. Again, we can only use quadrant 1. And now we have to figure out where are we going to do the graphing. So the first one, it says it has to be less than or equal to 15. x is less than or equal to 15. So less than, it's got to be to the left. So I'm just going to put a point to the left in each of those parts. The next one, y is greater than or less than 35. So 35 is this horizontal line. It's got to be below that. So I'm going to put a point below that line. Okay. And then it says y is less than or equal to negative x plus 40. So that's this upper diagonal line. So it's going to be less than that. So I have a point here, 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 and here. Actually, it could be not here. And then we need the fourth line. We have got to be greater than the bottom diagonal line. So greater than that. So that means it's got to be here, 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 or here. We need to shade all the parts that have all four colors. And the only part that has all four colors would be this area right here. So this is where our solution would be for this particular problem. You may do the last one yourself for extra practice. Your assignment for next time will be lesson 109, numbers 1 through 3, 5 and 6, 11, 15, 18, and 20.